Everybody, it's good to be here. This is a cool venue. I've been so glad the projector works. I hope you can tell my accent and my voice. I know no German and no French, so it's not English. So this talk, I'm going to keep track of time because I tend to go on. I can easily talk for like 3 hours on this talk. I'm going to try to talk about mostly Apache Camel and then maybe a little bit of cloud stuff at the end. Could we go forward a slide? Maybe 2 slides. I'm going to talk about what is this Apache Camel thing, if we've got time, a little bit of cloud stuff, and how you can use Apache Camel in the cloud. Okay, slide. Okay, let's start with integration. So, integration seems really simple to start with. We've all kind of been there. Your point-to-end boss comes to you and says, can you just parse this file and put the rows in this database, or can you just call this database and put the values on this message queue, or can you just grab this data from this FTP site and just copy it into this ETG, whatever it is. And then integration starts really simple, it's a really simple thing. You get out your FTP library and you get that your JMS name and you wire stuff together. And then the company that you were getting the data from goes bust, or you buy another partner and then something else happens and something else happens. And then a year goes by and then you look back and everything looks like this. You can't remember what anything is, there's all this glue everywhere, everything's duct tape, and 20 different people have written all these bits of tape and you've no idea what anything is. Okay, so integration is kind of simple to start with, but it soon becomes a big ball of mud like this. Okay. So Apache Camel came from having lots of integration in and trying to make that really simple. Slide. Slide. Yay! Okay, how many people have read this book? Oh, good crowd. Okay. So, hey, it's even in the audience. Great. Extra brownie point. So there's also a book came out which really helped, all of the various pattern books really helped us understand IT in general. IT is kind of complicated. So there's the NDC pattern, there's all the design patterns like factory, facade, and template method, and all that stuff. The enterprise integration patterns give you this nice high-level abstraction on how to do integration. Now integration can be kind of complicated, but really if we boil it down to some core patterns, it becomes much more simple. Now, at first you might read this book and kind of go, yeah, there's some patterns in there, yeah, so what? But patterns really raise the abstraction level of you and your team. It gives you a language, you can discuss things with your team and say, oh, let's do a content-based router and then a message translator. And you both kind of get it. You don't have to get out a huge lot of Java code and go, this stuff. It gives you a nice, high-level, simple language to describe integration patterns. Okay, slide. I should get a remote thing one of these days. So here's a bunch of patterns. There's about 50 or so in the book, and you can see them. There's maybe 2 in the book. There's a kind of core that you tend to use all the time. These are the really common ones on the slide. Slide. So what is Apache Camel? So Apache Camel is an Apache licensed open source implementation of the enterprise integration patterns. Now it's not an ESB, it's not a platform, it's not really a framework. It's a small little library. You can use it in a front end, you can use it in a web server, you can use it in a standalone Java application, you can use it inside an ESB, you can use it in a message broker, you can use it as a services client, you can use it in a server, use it anywhere you like, use it on a cell phone. It's just a bubble Java code, okay? So don't worry about like architectural decisions and servers and big rectangular boxes that you can your boss about. It's a simple library. It's easy to use, it's no big deal. Relax, it's fine. Slide? Maybe 2 slides. Let's get to the interesting stuff. Sorry. Another slide. One more. Yay! Oh, another one. Okay, let's start with the hello world kind of pattern. So we have a pattern called a message filter. This is probably the simplest enterprise integration pattern. You've probably done stuff like this before, but just maybe just call a message filter. The basic thing is we have these quote things here. We have a widget quote and a gadget quotes. And we have this thing over here that can only deal with widget quotes. If we give it a gadget quote, the thing would blow up, it would crash, errors in the log, it would shut down, it would be really, really bad. So we need to filter out the gadget quotes and just give the widget quotes. Now the enterprise integration patterns book talks a lot about messaging and messages. And people often assume this is all about JMS and stuff like that. When you hear the phrase message, just think logical message, think business email. This could be a rolling flat file, this could be a tweet, this Rover file on an FTP server. This could be an atom entry, a Rover database, a Java bean in a linked list. It could be a JMS message, or an MQP message, or a JavaSpace message, or a row from a Hadoop file. Think conceptual messaging here, right? It doesn't depend on any particular middleware. So think logical messages coming from somewhere. Okay, don't worry where they come from. We want to filter them and then send them somewhere else. Slide. So here's your very first camel route. Now this is in XML, and I apologize if you're not a pointy bracket kind of person. This is using pointy brackets. But even if you don't really know camel at all, this is the first time you've seen it, you can kind of figure out what it's doing. It's saying from active cubed, if you ignore the punctuation for a second, and just look at the words. From active cubed quotes, filter, that's the pattern name, this is filter. XPath, there's some XPath stuff to do the filtering, and then we're going to MQ series. Now that's XML. It's in this namespace, the camel spring namespace. And if you do next slide, how many people do Spring, by the way? Quite a few people, not a lot of people. So I guess those people who put their hands up, you do Spring XML projects. So this is now a Spring XML. So this is a regular Spring XML. The top blob is pretty much what you copy and paste whenever you write a Spring XML. Apart from we've added this XSD, the 1, 2, 3, 4, 5, the seventh line is a camel XSD thing. Because all namespaces in the Spring XML have to be validated with XSD. So that adds the camel namespace. But apart from that, it's a vanilla Spring XML. So you copy and paste this into your Spring app and you now have camel inside. All you need to do is add the camel Spring and the camel core journals and you're good to go. So this camel context thing is a little bit like an application context in Spring. It's a context in which you put camel routes. You can have one or more routes or zero or more routes inside there. And each route can represent flows or patterns. So now we have a regular Spring XML, we can just put it up and it will just run. Okay. Next slide. Now, there's a few essential pieces of a camel route. Whether you're looking at Java or XML or whatever, there's the patterns themselves, so like the filter tag, that's the pattern. There's the routes. A route is just a container of patterns or steps. Then there's a couple of other things. There's expression languages, so there's the XPath stuff. And there's URIs and there's components. Slide. I'll just go through those in a bit of detail. So expression languages. Now don't panic if you don't use any of these, it's not a big deal. But often when you're taking messages from somewhere and filtering them, transforming them, implementing various patterns, you often find expression languages to be useful. For example, if somebody gives you a blob of XML and you want to look in the XML and find out if it's a large order for a big customer, writing a big blob of Java code to navigate a DOM structure can be kind of verbose. Now you can totally do that in Camel if you want to do it, and that's totally fine. But sometimes a little XPath expression is the quickest way of navigating through a lot of data, pulling out what you need to get into the next thing. So XPath and XQuery are really good for working with XML. You don't have to use them, but they're there if you want to. There's a whole bunch of scripting languages now on the Java platform. EL is the expression language from JSP and JSTL. Spell, Spring, EL is the expression language from the Spring framework. There's Ordinal and MVEL, which are kind of more old-schooly versions of the Spring expression languages. There's also loads of scripting languages, Bean Shell, Ruby, JavaScript, PHP, Python, and Ruby. So you can use all of these expression languages as ways of creating expressions on which to do filters or expressions. So expressions crop up quite a bit. Don't panic if you use none of these expression languages. Just use Java code. Java code's fine. If you want to use Java code, it's fine. But if you like any of these in particular, like XQuery or XPath, if you like XPath, have a look at XQuery. It's kind of XPath, just a bit more. But both of those are kind of similar. If you work with XML, they're really, really good. Apart from if you have namespaces, and then they're kind of problematic. But so long as your XML does have namespaces, XPath is awesome. But by all means, just use Java code, it's fine. Next slide. So the other thing about Camel is, Camel uses, there's kind of three concepts and they're all kind of related together. Camel has URIs. So remember in the first slide we had AxionMQ, topic, quotes, and we had MQ series, now those are URIs. A bit like when you're linking to things in a web page, you use a URI for HTTP : or mail to : or file : Camel uses the same kind of URI mechanism to refer to endpoints.
And all the Camel labs work on sending and receiving endpoints, which are just simple little beans. Now what we found with Camel is we try and promote convention level configuration. So we don't really want you to have a megabyte long string XML with 1,000 beans in there, all wired up with getters and setters. What we kind of want you just to do is refer to endpoints and things just work. And everything auto defaults to the right configuration. For example, let's say all you're using is MQ series. You have my sympathies, activity is way better, but let's say for the sake of argument you're using MQ series. You're probably using lots and lots of queues in MQ series. Now you probably don't really need to configure every single queue on MQ series with its transaction manager and its connection pool and its security context and yada yada yada. What you probably want to do is configure the connection factory and then just refer to named queues inside that container, right? Similarly, on the web, you don't configure every URI in a string XML, right? You just type the URI to your web browser and it just kind of works. If you connect to an FTP server, connecting to the server you configure, but then talking to each directory inside the FTP server, you don't need to configure. So often in endpoints, there's kind of like a component which looks after connecting to the thing, and the component can make lots and lots of endpoints, which are kind of just names. Right? So a message queue has lots of queues, which are just names, lots of topics, which are just names. An FTP server has lots of directories, they're just names. You don't have to configure them. Right? If you really, really want, you can configure every single endpoint as a bean by hand. Knock yourselves out, it's a free country. But the idea is, we'd rather you configure just the component once with all the things it needs, and then all your camel apps can refer to any endpoint within that component, and life's simple and you can get each other. So Camel has this kind of thing, URIs and names, those strings, and those strings are turned into endpoints. And the magic trick, the thing that takes the string and makes the endpoint, is what we call the component. And all a component is a Java bean, which takes a string and turns it into an endpoint. So, for example, a JMS endpoint will have a connection factory and will just spit out queues and topics based on the name of it. An FTP server will spit out a directory on a remote FTP server and understand how to talk to it. So Camel has zillions of components. Next slide. It's a nightmare trying to keep the slide up to date. The last time I think we had 122 components just on the Apache side, but then outside of Apache there's loads of them as well. So Camel can talk to message queues, NTP, Java spaces, Hadoop, Google App Engine, FTP, HTTP, sockets, multicast, Java spaces, JPA, Hibernate, MongoDB, pretty much anything you can imagine. Pretty much every kind of middleware protocol, transport engine, transport protocol, template engine, transformation engine, there's usually a Camel component already. If there isn't a Camel component for the specific thing you want to talk to, writing one is really, really simple. Find the one that's the nearest you can see and just copy and paste it. You can totally do one by hand from scratch and that's fine too, but there's so many Camel components out there, it's easy to start. Find one that is kind of close to what you need and just switch it. So there's lots and lots of them. One particularly interesting one, if you ever find you have to talk to some really legacy, crappy old system that somebody hand wrote an API to talk to it, and you have to open a socket and write some weird magical bytes stream to it to talk to it. Apache Mina, there's a Mina component, there's a library called Mina at Apache, which is a little framework for doing UDP, multicast, and TCP sockets. It does all of the kind of the sockety crap for you. You just plug in a little marshal that understands how to read and write from a stream, and wire that in, and you've then got a Camel input. So you shouldn't have to write Camel components by hand, really, but if you really have to, go for it. If any of the Camel components you see you don't quite like, or you want to work a different way, just follow the code, hack them. They're just little bits of Java code. All the Camel endpoint is and Camel component is a couple of beats, so they're really quite simple. I say simple, they're all really simple apart from the JMS component. If you look at that, that's really simple. But luckily you can just use that one. Okay, next slide. And one more. So that's the XML version. Now if pointy brackets hurt your eyes, we might have a slide for you. Hooray! No more pointy brackets. So here's a Java DSL. So one of the things we really tried with the Camel project was to raise the abstraction level of doing integration. Now, it's not just about having competitions of who can write the least code, although that's kind of cool too. It's about how we can describe what we mean in the smallest, most concise way possible, so we can all understand what we meant when we wrote the code. I don't know about you, but I work with lots and lots of code all the time, and time progresses, and my memory is not as good as it used to be. And I can look back a year ago at something I did, and I have no idea what I was thinking. And if it's a big blob of code, I'm just lost. What the hell is this crap? What we're trying to do with Camel is raise the abstraction level, so it's kind of obvious what you're thinking when you wrote it. So teams come and go, people move from job to job, or you might just not have the best memory and not remember what you did last month, last year, last decade. So this helps you, rather than saying a ream of Java code using some magical middleware API, you see a simple thing that says, oh, I'm taking stuff from the code and I'm turning it into a series, and I'm doing it function. So it's nice and easy to comprehend and easy to understand. So what we did with Camel, we have an XML domain-specific language, or DSL. We have a Java DSL, there's also a Scala DSL, a Ruby DSL, a Ruby DSL, a Scala Z DSL, a Z, and a Nessus DSL. So there's lots and lots of different DSLs. Now, the core thing about Camel is all of the different domain-specific languages make the same underlying model in the code. So it doesn't really matter which one you pick. Use Java, use Scala, use Ruby, use XML, it's totally fine. Once something's running at runtime, you can inspect the process and get the model back. So Camel keeps track of what the model looks like. In other words, what the logical patterns are that they're running. So you can look in production in a running system and see what's running. You can see the picture, irrespective of whether the person is Ruby or XML or whatever. Okay. So here's some Java code for send route. And again, we can read it from adding a queue, filter the next path, send empty series. So it kind of makes sense, it's easy to read. It's almost like English without the symbol. The other thing is we tried to make sure we could write all of the enterprise integration patterns in one line of code. I've done a couple of carried returns here to fit on a slide with big text, but it's one statement in Java. Okay, it's multiple expressions, and we'll be pushing the one line of code a little bit, but it's technically, there's one semicolon on the page. This is Java after all. Okay, next slide. Those of you who write lots of Java will know you can't just write function calls. You have to wrap it in a function and wrap that function in a class. So here's how we turn the DSL into a real Java class that your IDE will compile. So the basic trick is you extend router. Now IDEs, Java IDEs may be these days. Certainly Eclipse, IntelliJ, Netbeans is okay. IntelliJ, but anyway. But then whichever you use, they're all about the same. Give or take. So you write a class, you extend route builder, your IDE will then complete the import statement, it will then complete the configure method, because configure is an abstract method, so your IDE will go, oh, you're creating a class, you extend the route builder, I best implement the configure method. So you get this, all the plumbing just appears by importing the IDE. All you have to write is the from. So you type from, your IDE completes, and you just provide a route. Now, these days in APIs, it's getting kind of, it's trendy to use annotations for everything, not use inheritance. But we're old school on Camel group, so we use an extend, we use inheritance here. Now, the reason we're using inheritance is to add the domain-specific language into this class. So the from method is a method that's available in route. Next slide. Just for comparison's sake, here's a Scala DSL. We don't have to say from, we can just use strings directly. We can use arrows as well to do sending messages. And here we're using when, which is a message filter. And then in the parentheses, we're using, okay, the underscore looks a bit weird. If you haven't done Scala, don't worry. The underscore is a Scala thing, it's an optional thing. And basically we're using Scala as the expression language. So the thing in the parentheses is a filter, where we're saying, is the in message equal to hello? Is the payload equal to hello? And if it is, we're going to send it to this endpoint, which is called multiple. Don't worry about the Scala thing if you don't know Scala. Next slide, but just for comparison's sake. Okay, so let's imagine we've written some routes, and how do we then, and let's say we're using Spring, we've written some routes, how do we make them kind of run and start up? So here's one way of doing it. We can get Camel to do package scanning to find all of the classes in that package, which implement route builder. And then just suck all the classes up, instantiate them, and run. Okay, so that's one way. Next slide. Here's another way, if you're a bit more old school and you don't use a framework. So if you're just using Java code, there's no Spring, there's no dependency injection, there's no auto lifecycle stuff. You're just writing Java code. You create a context, you add some routes, and you call start. Nice and simple. And if you really want, you can call stop again, but that's a good story, which isn't very useful, but that's nice on the show. Next slide. Here's just a quick example of, which is good today because I'm nowhere near my laptop, of how smart completion works in an IDE. So here we're writing a configure method, and notice how when we do the key press, whatever the key press is in your IDE, I just call it splat in my head. I don't get my fingers pressed, but press something, and completion pops up. I think it's all space. But I go like that, and it just happens. I've done it for so long, I can't remember what key press is at the moment. I think it's all space on that. Anyways, you press the completion key on your IDE, and you get a list of all the patterns that are available. So if you can't remember the pattern name, just do dot splat, it keeps scrolling and you'll see one. As you hover over the different patterns, you get the Java doc. The Java doc gives you a brief overview of each pattern in turn, so you can quickly scroll through the patterns. So if you're looking at some code we've never seen before, you can just look at the Java doc, see what the pattern is. If you click on here, it takes you to the Apache Camel website where each pattern is documented, with examples, reasons why you use the patterns, things to look out for, alternative patterns you might want to consider, and so on and so forth. So you might find the pattern really applicable, and nobody else in your team might have seen that pattern. But it doesn't really matter because it's trivial to navigate from the code to the pattern, to the documentation, to the examples. So if somebody uses a pattern you've never seen before, you might see recipient list. What the hell is the recipient list? Just one click in your IDE, you get the Java doc, you can read all about the pattern, find out what the pattern's for, why it's really nice. Next slide. If you're a pointy bracket kind of person, that's cool and all. I'm sure there's therapy for that. Pointy brackets are really good. You still get the smart completion in the pointy bracket language. The only downside is we don't have much comments in the XSD right now, so we just do name completion. One of these days, we generate the XSD using JAXB, and one of these days, we'll hack the JAXB conversion so we can put the Java comments in the XSD. One day. Next slide. Next slide. So a quick recap. Oh, already over already. Awesome. So a quick recap. Camel's kind of simple on the surface. It's like a lot of things in IT. It starts off really simple. You can dive as deep as you like. There's a lot of detail. But the high-level concept is enterprise integration patterns. It's really simple. They're easy to get going. Really easy to read, communicate. When things are running, you can visualize the things that are running. So you don't just have a JVM full of random view. You can connect over JMX and see the patterns that are running in a running process. We have patterns, we have expression languages which often use different patterns, for example, filters. We have endpoints, URIs, and components. What we haven't really talked about yet is there's a test kit. So we kind of wrote everything the wrong way around at Apache. We should have done the test kit for Camel first, then Camel, then service means then FTMQ, because then we could have tested everything really well as we wrote it. Whereas testing distributed asynchronous systems is really hard. And we only realized how to do it after failing badly for many years. And then we wrote the test kit Camel, which is really nice. I wish we had that 10 years ago and started with that, and then everything was tested really well. But there's a really good test kit where you can test Camel or any endpoint that Camel can talk to. So if you ever need to do integration tests with things, you might have a couple of systems and you need to send some messages into one of them, and you need to call some messages come out in some way, or pull that database, have the right data, or files pop out to a directory or something. So if you ever want to test a black box, the Camel test kit is really, really useful. I don't have time today to talk about the detail. Check out Camel testing, it's really, really nice. The basic idea is we use a Camel route to send sample data into a test system, and we use Camel routes to consume messages from the output. We use Camel to transform and filter the things we actually want to test and make assertions on, and we wire those messages into endpoints that are called the mock endpoints. And on the mock endpoint, we can have assertions that says, I expect to receive 20 messages with no duplicates, with incrementing order IDs. So you can incrementally add more and more assertions to your integration test, and have an integration test done in this much code. Next slide. And bees. Next slide. So beans were a common way of working with Camel. And I think a lot of people start with Camel thinking there's going to be a pattern for absolutely every piece of code you never want to write. The patterns aren't really like that. The patterns are quite high level. And now and again, if, I don't know, you need to take a purchase order and do a foreign exchange conversion to turn them all into euros, and then calculate the average amount of an order, there isn't an enterprise integration pattern exactly for that. But there is a message translator pattern that lets you transform a message into something else. So there's times when you have to use some code. Okay? The patterns aren't meant to solve every single problem. Sometimes you need to drop down to good old-fashioned Java code, and that's fine. So beans are when you kind of plug in real Java code, where you really want to write some business logic or something. So here's an example where we're consuming some messages. We're going to call a bean of a name called my bean. So for the Spring people in the room, that's kind of like looking up a bean by ID, getting the bean and then calling a method of the bean with the message payload, and taking the result and sending it on here. Okay. Next slide. So you might think, well, what does that bean look like? Well, there you go. Okay, so it's a nice simple Java bean with a method, and it's a parameter that takes the payload, and it's the return type outputs the result. Now, our recommendation on the Camel team is, if you're writing integration code, you will at some point need some business logic stuff. Business logic might be, I don't know, doing a currency conversion, or looking up some static data, or enriching a message with some business data, or doing something. When you're doing business logic, try and keep all the middleware away from that code if you can. If you can keep business logic devoid of middleware code, it means you can test that code really simply. You don't need a message broker or a big massive system to test that logic. You can just create that bean, find the message, see what comes out, and you've got a test case. So this is a really simple to test piece of business logic. It's not the most complicated business logic you've ever seen, but it's really easy to test, right? If you write JUnit, I can invoke this method, and life's good. There's no Camel APIs here, there's no JMS APIs, there's no Hadoop APIs, it's just nice and simple business logic. So try and keep your business logic in your beans simple and with no middleware APIs. Because it might be you start off using file systems, and then you soon realize your business might acquire a number of other partners, and then scalability becomes an issue, and then you have to switch from files to databases, and you realize databases aren't too important for real time, and then you have to go through the message queues. Or you go from database to NoSQL to Hadoop to MongoDB to whatever. So if we find that the middleware often changes based on business requirements, which is fine, you don't have to keep rewriting all the code though. So if you keep the middleware out, it becomes much more usable. Next slide, please. Now here's an example of a simpler way of doing the first route. Often routes are quite simple. You write a bean, it's going to consume a message from somewhere, and it's going to do some processing and send the results back. There's no need to have a route and a bean and wire them together loosely like that, because that's not really refactory friendly. What you can use is annotations on the bean if you've got a simple route. In other words, if you've just got a bean which is consuming from a Camel endpoint, it's simpler just to put a consume annotation. So this is a Camel consume annotation. Now this looks a bit like a message-driven beans if you've ever done any message-driven bean stuff. There's a couple of massive differences there that might not be really obvious. The first one is this accepts any Camel URI. So this can consume from a message queue, MQP, a file system, MQP, Java spaces Hadoop, MongoDB. So this works with those 122 components, which is so this isn't just a JMS, it can work with any bit. The second thing is a massive difference is this implicitly can do request reply and ordering messaging. If you use a message-driven bean, it's kind of a big deal when sending the messages back. You have to create a connection factory in a session with a producer and send them, close everything down. It's just a Here we can just return a value, and that will send the message right back. So we can get quick and easy sending of results back. Sending a result back differs on different middleware. If you're using email, how to send a message back is usually a reply to a header rather than an email. If you're using JMS, it's the JMS reply to a header and the JMS API. If you're using HTTP, it's pretty much the socket request. So all these different middlewares often have a way of replying to messages. Camel and Camel components deal with all that crap for you, so you don't have to worry about it. All you have to do is return a value from a method, which is one other big difference, which we'll talk about more in the next slide, is if you're using message-driven beans, you're given a JMS message as the parameter. Which, JMS, I like a JMS. The problem is, it's kind of a bitch to use a JMS message. Let's imagine a simple example. Somebody's sending us a string of JMS. So the JMS API will give you a JMS message with it. And then you say, okay, are you an instance of text message? Yes. Okay, cast into a text message, pull out the get text. We could get string get text up here. And they say, oh, but are you a map message? Oh, yeah, you're a map message. Okay, well, look in the map and pull out the value that could probably be called text. Or are you an object message? Oh, you might be an object message. Okay, cast to an object message, and then pull out the object, and then turn that into a string. And before you know it, you've written 5 pages of code just to get the goddamn string. Right? In Camel, you just say, give me the string already. I don't care. Right, so in Camel, you declare in the method, in the prototype, you say, give me a string. Now, it doesn't have to be a string. In this case, they mention it's a string. You say, give me a string, and let Camel deal with unwrapping the crap from the line. Okay? So you can just get on with your job, you can process your string, and get on with life, and get to the next thing. Meanwhile, Camel has figured out, is it a message, is it an object message, is it a map message? So Camel deals with types, and type conversions, it deals with middleware abstractions, and it deals with request reply, all under the same simple way. So it's much, much better than message driven bean. Please never write another message driven bean again, please. Next slide, unless you've been doing that. Okay, now sometimes you don't want a string, and that's fine too, either, but there's more to life than strings. So you can use any type, and I'll call it the type conversion. Sometimes though, you want different pieces of the message. So different middlewares have got things like headers. If you're using HTTP, you have HTTP headers. If you're using JMS, you have message properties on the header. If you're using HTTP, that's got headers, email's got headers. So as headers. A lot of transporty things have headers, which sometimes you need. Let's imagine I'm using JMS. I might want to get the JMS correlation ID from the message. So I want to get the payload and the correlation ID because I want to use that somehow in my business data. So we can just use the @header to pull out different headers from the payload. Now, again, we're kind of doing middleware stuff here, but the API is just taking strings. So I'm not putting any JMS code in my library. I can call this with 2 strings from any Java code I like, but it's doing the necessary Google codes. The other nice thing is I can still use all of the Camel expression languages. So I can use XPath and XQuery and JavaScript and Ruby and blah, 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 by using an annotation. So I might just want to pull out 3 or 4 little things from the message. I might have a huge blob of XML as the message, and all I really want is 2 strings. So I can use XPath to pull out the pieces I need. Rather than giving, now what you could do is just turn it all into a DOM and say, give me the whole of the message as a DOM, and then you can walk the beautiful DOM API as part of the JDK to find the thing you really want to use, which would be like business Java code. Or you can just use a simple XPath to pull out the bits you need. So rather than having to manually walk DOMs and things like that, you could just use @XPath, pull out the bits you need, and use it to go. Okay, next slide. I talked past it, but if you clicked on the link on that last slide, you'll download these slides somewhere as well. There's a whole raft of annotations you can use to pull out different pieces of the message, which are on the link. Here's an example of doing the other way. We're going to send a message. So we're in the middle of some random Java code, and we suddenly go, hey, let's send a message somewhere. It could be to a flat file, to a database, to a Hadoop, whatever. We're going to send the message to one of those components. We can use this @produce. Now, @produce is slightly different. We don't annotate a method. We annotate a field or a property, and it will inject an object which we can then use to send messages. So here, we're in the middle of some random code, and we just say producer.send object. If you use Spring, there's all these template objects which have all these little helper methods for doing things. The producer template is a Camel interface, which has a whole raft of different methods for sending a message with a body, with a URI in the body, with a URI and some headers in the body, for sending one way, for doing request reply, and all this kind of stuff. So there's a whole raft. If you do producer dot, your IDE will give you a whole host of interesting things you can do with the box. Next slide. Now, this is a way of getting rid of the Camel API. In the previous slide, we had the producer template there, and I kind of said, don't ever use a middleware API, and Camel's kind of middleware. Okay, so if you're ever going to use a middleware API, make sure it's a Camel API. Just don't use the other middleware API. But if you want to get rid of the Camel API as well, here's the way of doing it. We're going to make our own interface for the thing we're talking about. We've called it My Listener. So MyList is just an interface we've made up. We control the API, we refactor it whenever we like. We now inject MyListener and we call say hello. Because we've annotated with Produce, we now have no Camel APIs, we just have annotations that are not an API. It's cheating, but technically it's not an API. So now what Camel does is it injects a MyListener, which is a dynamic proxy, which when we invoke the method, it basically sends a message at the same time. So here's a way of sending a message in a type-safe way that's easy to test without using Camel. Now you might say, why would I do such a thing? Well, this is now easy to test. You can implement MyListener however you like in a test case and inject that in yourself and test this piece of code without actually sending a message anywhere. So it's really easy to test it. Next slide. These are 2 books. I get no commission from either of these. Honestly, I don't. I probably should, quite frankly, but I don't. But they're both really good books. I recommend both of them. If you're doing academic review, it's really good. If you're doing Camel Action, it's really, really good. I'm lucky enough to work with both authors of Camel Action, John and Klaus. They both work with a few sources, and they're both awesome. And I have worked with all 3 authors of the Camel Action. One of the authors there doesn't work with a few sources, but the other 2 do. The other ones do less than that. But both these 2 books are awesome. Next slide. Here's a quick flash of Fuse ID. If you're using Camel, I highly recommend Fuse ID. It's a free Eclipse plugin. You can download a full distro with Eclipse, or you can use an update site to just update the plugins, and it lets you edit and run and trace and Camel routes and visualize using Camel routes and many processes and so on. It's really, really good. Don't have time for demo right now, it's really cool. Go to fusesource.com and there's some screencasts that show you in action. Next slide. Cloud Schmau. Now let me just see how much time I've got, so I can probably over. Oh, I can do a little bit. So I was just going to talk a little bit about cloud and Camel. Okay, next slide. Because cloud is the latest buzzword, which is why I kind of hate it already. But it adds a different dimension to integration. So we've been on this progressive level of abstraction in computing. We started off with the operating system, which abstracted how we talk to disk drives and networks and so forth. And then we abstracted the operating system details and APIs behind virtual machines like the JVM, so we could run the same program on any operating system, and that was one level of abstraction. And then we started to abstract the entire operating system, so we could run any operating system through virtualization of hardware. And now we're starting to virtualize physical machines with virtualization. And now clouds come along as the next kind of layer above, where we're now abstracting collections of computers that we just boot up. So we've been on this steady progression of abstraction. Now, I think the unfortunate thing is when you hear cloud, it reminds you of a million vendors trying to sell you something. But I prefer to think of the concept of cloud as in, it used to be really, really hard to get machines and configure them and install software. Now, however you do it, it's really simple to get lots and lots of machines, control them and provision them, and configure them, and get stuff done. So to go from 2 machines to 5 machines to 20 machines is really easy to do. Right? It doesn't necessarily mean you have to run all of your operations on Amazon EC2, and it doesn't mean you have to drop your pants to VMware and give it lots of those money. There's lots of ways of using cloud and stuff right now today. To have some kind of cloud to run your software, to provision and install and configure your software. Next slide. But cloud complicates things in integration. So a lot of the people who are doing cloudy stuff right now tend to be doing like web apps. Web apps are really, really good because you're running like a Tomcat or a Jetty. You're running like one thing and you have a little load balancer in the front, which you haven't used. And you just run lots of these Tomcats and you can go up and down in your Tomcats. And all the Tomcats talk to a database. And life's really simple. It works beautifully in the cloud. And all the demos you see of clouds, they're all, you run a Tomcat, there's a little load balancer, and life's really simple. Integration, though, is really hard. Most of the customers we deal with, their integration problems are really, really hard. There's hundreds, sometimes thousands of different systems all talking to each other. And when you try and do that kind of stuff in the cloud, it's a nightmare. Because it's not one thing that you run a lot of. It's 1,000 things that you run arbitrary different numbers to. And they all need to talk to each other. So that the cloud totally changes integration in a way that it becomes much, much harder. Okay, next slide. Now, I could talk a lot about this last section. I'm going to try and keep it short so we can do some questions and answers. My generic lesson for you all, if you're doing anything vaguely cloudy and anything vaguely integration-y, well, just anything cloudy, frankly, my hot tip is use messaging. Okay, so one of the biggest problems is, as soon as you go cloudy generally means dynamic-ish. I'm going to boot up machines somewhere, they're going to have some random IP address, we don't know what the IP address is going to be. I can boot up 20 machines here, 20 machines there, none of the machines know what any other machines are, it's just an argument. Right? So the trick is, go for loose coupling. If all of your systems communicate with each other via message-oriented AMQP, ActiveMQ, JMS, whatever you want to use, if you really have to, consider it, or if you've already paid for it, if you haven't paid for it already, don't touch it with that problem. Please go for one of the open source alternatives. They're much easier and simpler to get going when you're using it. If you have to increase them, it's fine. But the really nice thing is, if you have a messaging system, all you need to know is where is the messaging, right? So you have one string to configure. So you have 20 boxes here and 20 boxes there. You configure the one string, and everything connects to the message broker, and then everything can talk to everything without knowing where anything is anymore, right? So you don't have to hide everything behind the HTTP load balancer, which tends to be crap. And then trying to figure out URI paths for everything, which is a dilemma. Just use messaging, it becomes really simple. If you have hundreds or thousands of different systems, they're all talking to each other. Another common thing people forget is life cycles. All of those thousands, now if you're really lucky, you release everything together. Well, lucky or unlucky. You might release every one of these 1,000 systems at the same time. And then if you have to make one little change in one of your 1,000 systems, everything comes down and then everything comes back up again. Right? That might happen. What usually happens is all the time stuff's coming up and going down and changing, moving stuff all the time. Now, if everything's wired together with sockets and physical IP addresses, as soon as something goes down, stuff starts breaking and locking and hanging and threads go like this and contention and you have to keep rebooting, and it's just a nightmare. If you've tried it, it's bad. The really nice thing about messaging is it's loose coupling not through just physical hardware and IP address, it's loose coupling by time. So you can have all your 1,000 systems communicate with each other over, say, queues, and you can take one of the systems down, it can be down for a week. If you plug to your disk, it really doesn't matter, you just have some queues that grow and grow and grow. It's very easy to monitor the queue depth, so you can see, oh, this queue's getting really big, maybe something's there. Somebody might have pulled the cable out. Everybody knows if your 1,000 things are running, right? The queue depths are a good little warning that things are not good right now. Maybe we should do something about it. Right? So if everything's sockety stuff, you could be trying to post to a socket and you're in a retry loop, whatever, never. Nobody knows. You're sat there trying to post, socket found, nobody knows, right? With a queue, you can see it growing, and alarm bells can fire. So having your message queue in there really helps your location transparent and your time transparent. The system can come and go, and you're good to go, right? Assuming you don't have any user interfaces with request replies. Put the user interface to the side. Everything else apart from the user interface, do asynchronous messaging and loose coupling, and it saves a lot of problems. So that helps a lot with most things. Okay, next slide. But that's not always enough. So a lot of our customers have got lots of pain at running lots and lots of integration solutions across lots of machines, often in lots of geographic locations, and they need things like federation and clustering and load balancing and distribution and yada. So there's this other open source project called Fuse Fabric, which I'm going to talk a little bit about. But if ever you need any cloudy, camel-y stuff, have a quick look at it. It's basically a Apache license. It's like Camel. It's simple, like weird. It's really simple. Next slide. I'm going to best talk really quickly because it's time for questions and answers in a minute. But it basically kind of looks like this. There's like a runtime registry in the middle, which is based on Apache Zookeeper, which is like a highly available HA. Kind of like a distributed JNDI, but not in a bad way. It's like a real-time hash map thing that's really good for doing discovery and failover and sharding and clustering and master slave, coordination and all that kind of stuff. It's awesome. It's awesome. So we have this Zookeeper in the middle. We use Zookeeper for discovery and configuration. And we then, around the side, we have Eclipse tooling, and then we have this little agent that sits inside the JVM that is used to communicate with the cluster. And we can do various things like distributed configuration, discovery, load balancing, federation, and so on and so forth. Next slide. I'm going to summarize really, really quickly here because we're running out of time. But basically, we can use this to do distributed coordination and configuration. For example, if you've got 1,000 machines, you probably don't want to have to SSH into all those machines to change a thread pool size or to change the database connection pool size. Now, what you're probably doing is you're doing one of two things. You're either SSHing into lots of machines and using Vi, or you're uninstalling things and installing things again, using like a chef or puppet to reinstall everything in Vi, which is fine as well. What we've used with Fabric is we've got basically a distributed configuration, so we can centralize all the configuration and replicate it out to the rest of the system. Now, changing 1,000 machines' thread pool size is potentially scary. You probably don't just want to do that globally in real time. You probably want to try it on 1 or 2 machines first and see, does it break? So you try one machine, you leave it running for 10 minutes, so you go, okay, the keys are wrong. Let's do another machine, yeah, all right, number 10. Oh, I'll remember. Go back. So you probably want to do rolling upgrades, right? So we have rolling upgrades so we can migrate machines from configuration to configuration. So you don't have to remember which 3 machines did I SSH into to change some setting because things are going bad. You can just roll forward and roll back in a really simple way. The other thing, the bigger thing for Camel in plan is we have a runtime registry that needs for discovery and load balancing. So if you can't use messaging, now always try and use messaging. And if you can't use messaging, if you have some legacy stuff that has sockety crap, or you have to do some web servicey stuff or whatever the case may be, we can use dynamic load balancing and discovery over that, which I'll show you in the slide. Next slide. So the first thing that Fuse Fabric can do is it lets you easily dynamically provision routes. So for example, you might release all your 1,000 systems, every single component in one big release. And you might try that a few times, and then you might think there might be another way of doing it. And then you might go for a more granular thing. As things change, you do more granular fine-grained things. But when it comes to integration stuff, that's often kind of duct-tape at the side. You might want to rev that in a different lifecycle to your software components. So you might end up having quite fine-grained camel components. You want to roll forward and roll backwards in a more fine-grained manner. So you can do this rolling forward and rolling back of integration solutions as infrastructure changes, providers change, hosting changes, and so forth. So we can use the rolling upgrade and the centralized configuration to make it really simple. Next slide. Okay, so if you're not using messaging, well, firstly, try and use messaging. But if you're not using messaging, let's imagine you have some really crappy HTTP stuff. Here's a way of kind of getting some of the benefits of messaging. It allows you to basically abstract the physical host and ports. So the first line of code is we're sending a message to an endpoint called Fabric My Name. So Fabric is a Camel endpoint which acts as a logical location of the service. So we can send messages to Fabric called My Name, and My Name is a logical name service. We don't really know where the service is running. Under the covers, the Fabric endpoint is using the Zookeeper registry to find the physical host names and ports of where those services are running. Now there's various ways of registering those endpoints. One of them is the next line of code. If we're consuming from a HTTP endpoint, so here we're using 000 for the host and the port to get the operating system to give us a host name and a port. So we're dynamically creating a host and port name on the machine. What the Fabric column My Name is going to do is going to find the real host name and port, put it in the registry, so that this is now a new instance that those line code can use. So what we're kind of doing with the covers is we're making a dynamic real-time registry of all the physical host and port names that we can talk to. And then the first line of code is using that registry to send to the physical endpoints. In other words, we don't need to hardwire host and port names. Now the nice thing is I can start and stop this second guy on any machine in the network and everything just kind of works. Right? We don't have to hardwire anything. There is no manual configuration step. We don't have to install and uninstall anything. The first guy, we don't have to start and stop if new things come online and go off. We don't have to stop it, change the config, run some code, change the thing, and then push it back up. How it works under the covers is we're using Zookeeper's. Zookeeper's got a snazzy thing where you can listen to the piece of the registry. So you can say, let me look at all the entries of the My Name part of the Camel cluster And in memory, I'm going to keep a linked list of all the physical host names and ports. So when you're sending to Fabric Color Mining, in memory, in that JVM, it has a linked list of all the real host names and ports, or all the actual Camel endpoints to talk about. So every time you send a message in the first guide, there's no network chatter, there's no RMI, there's no lookups, there's no database queries. In memory, each JVM knows what everything is. Now, as soon as a new node comes along or dies, Zookeeper immediately notifies anybody who's watching that there's a new server joining or server's died. So everybody's linked list updated in real time. So we have a complete real-time discovery of our balancing, which really, really helps. Okay, next slide, we're almost finished. Now this one, not everybody needs this, but if you need it, this is a damn lifesaver. So often you have a crappy legacy system in the corner of the office that somebody has to talk to, one process has to talk to, but because the system is kind of crappy, if two people talk to it, it dies, or maybe contractually you can only send like a message to it once a minute, or 10 a second, or something. And so if you just run 10 machines in the cloud and you all connect to it and start sending messages, the system falls down in the heap. So you want to kind of throttle access to a system or limit it, or sometimes people, particularly investment banking, you have to charge per connection. So you only want one socket open on that machine at any point in time. If that guy dies, you want another guy to open the socket and connect. Depending on your SLA with your other systems, this kind of thing can be really, really helpful. Basically, if you add master call on foo, go back. If you add master call on foo on the front of any endpoint, what it basically says is, elect a leader. Elect one JVM to be the master of that endpoint, and only one JVM will activate that route. If that one JVM dies, another JVM takes over. So you can guarantee for foo, there is only one JVM running at once. So there's only one physical connection to some URI. And you might not need this, but when you do, this is so awesome. Now you can have foo and bar and whatever. You might say I'm going to have 3 connections on this one system. You might federate it. I'll have one thing connected in London and one thing connected in New York. So how you define your foos and your bars is up to you. But when you need it, this provides kind of highly available load balancing of like a master or standby. So next slide. We're just about done now. So in summary, Camel rocks, buy the book, download Suits IDE, it's awesome. Get started on Camel, you'll like it, honestly, it's really simple, it's really good fun. If you're in the cloud, use messaging, it will save so much pain you probably even don't realize you would have if you didn't use it, so just use it. And if anyone wants to plan this Fabric, use Fabric, it's really simple open source that can really, really help. Any questions? We ran over quite a bit. Any questions at all about Camel?